In this video, let us solve more problems based on trigonometric ratios. So here we have the question. It reads like this. An equilateral triangle is inscribed in a circle of radius 6 centimeters. Find its side. So what we have to do in this problem is find the length of the side of the equilateral triangle that is inscribed in a circle of radius 6 centimeters. Now, first let us try and draw a circle of radius 6 centimeters. So let's assume this is 6 centimeters. And there is a triangle inscribed in it. Equilateral triangle, that's the most important part. So let's say this is an equilateral triangle. It is kind of cross or oblique, but it's okay as long as it's a triangle, it's fine. So now, what let's do is let's say this is the center. This O is the center of this circle. Now, let us say that this, let's join it. So this is going to be 6 centimeters because this is the radius of the circle. This is also going to be 6 centimeters. Let us also drop a perpendicular and let's name this ABC. And let us name this D. Now let's say that OD is perpendicular to BC. And so now let OD be the perpendicular from O on the side BC. Then D is the midpoint of BC. Now these are the basic rules of the triangles. Please do visit the previous videos of triangles and do try and understand these concepts if you do not seem to understand them now. So OD is a perpendicular on BC. So therefore D is the midpoint of BC, and OB and OC are the bisectors of angle B and angle C respectively. So therefore angle OBD equals 30 degrees because an equilateral triangle has 3 angles of 60 degrees each. So if OB bisects the 60 degrees, you're going to end up with 30 degrees on the left side and the 30 degrees on the right side. So now what happens is, in the triangle OBD, let's just consider the triangle OBD, which is right angled at D. We have angle OBD equal to 30 degrees and OB equals 6 centimeters. OBD equals 30 degrees and OB equals 6 centimeters. So now what we have to find is the side of the triangle. Now if we find just BD, it's almost done because BD is exactly half the side of this triangle. So if you find BD, we just have to double it to get the side of the triangle. So to find BD with 30 degrees, we need to use cos because this is adjacent and this is hypotenuse. So we need to use cos because cos gives you adjacent by hypotenuse. So now let's use cos 30 degrees, which is equal to adjacent by hypotenuse. Now cos 30 degrees is root 3 by 2. Adjacent is what we have to find, which is BD, and hypotenuse is 6. So therefore BD equals 6 root 3 by 2, which is 2 was 3 times and 6. So we've got BD alone as 3 root 3. But we need BC. So therefore BC is nothing but 2 times BD. So 2 into 3 root 3 centimeters, which is 6 root 3 centimeters. So therefore the side of the equilateral triangle is 6 root 3 centimeters. So again, this is nothing but a simple application of the trigonometric ratios, and all you had to remember was that which function you had to use in this case. If you would have used sine, what would have happened? Say I use sine 30 degrees. It is opposite by hypotenuse, right? It is opposite by hypotenuse. We would have found OD, but what is the use of finding OD? OD by hypotenuse is 6, sine 30 is 1 by 2. OD is 6 by 2, which is equal to 3. But what's the use of OD? We need the side of the equilateral triangle. Now, that is exactly why we had to use cos, because cos was helping us find BD, which is exactly half of the side of the equilateral triangle. I hope you understood the reason why we had to use cos and not sine. If you try and understand this particular concept, then it's almost pretty much done with applications of trigonometric ratios, at least in a simple way. So apart from that, you need to remember what is cos. If cos is adjacent by hypotenuse, or if sine is opposite by hypotenuse, what is what? If you know so much, It's almost done. So let us solve another problem before we complete with this video. So here we have another question. It reads like this. In an acute angled triangle ABC, if tan of a plus b minus c equals 1 and secant of b plus c minus a equals 2, find the value of a, b and c. So now let's take tan of a plus b minus c equals 1. Now we've got tan on the left hand side. So tan of what gives us 1? Tan of 45 degrees gives us 1. So now we can equate a plus b minus c equal to 45 degrees. This is one thing. Another thing is secant of b plus c minus a equals 2. Now since we've got secant on the left hand side, secant of what gives us 2? Secant of 60 degrees gives us 2. So therefore we can write b plus c minus a equals 60 degrees. So let's consider this as equation 1 and this is equation 2. Now let us add both these equations up. So we have a plus b minus c equals 45 degrees. And then we've got b plus c minus a equals 60 degrees. So a and minus a gets cancelled, c and minus c gets cancelled. We have b plus b, which is 2b, equals 105 degrees. So we have b equal to 105 degrees divided by 2, which is nothing but 52.5 degrees. So we found the value of b already, which is 52.5 degrees. So now what let's do is, let's put b equals 52.5 degrees in this equation. So we have 55.5 degrees plus c minus a equals 60 degrees. So therefore we get c minus a equals 60 degrees minus 55. Sorry, it's not 55, it's 52. It's 52.5. 52.5 degrees. So c minus a equals 7.55 degrees. So we've got c minus a as 7.5 degrees or 7.5 degrees. Now also in triangle ABC, we've got the sum of the three angles equal to 180 degrees, right? So say for example, we have something like this. A plus b plus c equals 180 degrees. And we have a plus 52.5 plus c equals 180 degrees. So we have a plus c equals 180 degrees minus 52.5 degrees. Let me continue that here. So I have a plus c equals 180 degrees minus 52.5, which is 127.5 degrees. So now what I've done is I've created two equations with the same variables in it. So let's add them all now. C minus a equals 7.5 degrees. And then we have c plus a equals 127.5 degrees. A gets cancelled. We have 2c equal to 135 degrees, from which we can find c equals 135 degrees divided by 2, and that is equal to 67.5 degrees. So now that we know two angles out of three, that is c and b, we can easily find a. A plus b plus c should be equal to 180 degrees. We need to find a. We know b, 52.5 plus 67.5 equals 180 degrees. So a equals 180 degrees minus 52.5 minus 67.5, which is equal to 60 degrees. So we found the value of a as well. A equals 60 degrees. So if you would have noticed carefully, except for the place where we used the trigonometry here, that is tan of what gives us 1 and secant of what gives us 2, apart from that, we've used the concept of simultaneous equations and then some basic problem solving skills. That is all, nothing else. So if you consider this as a chapter of or a concept of trigonometry, there was not much of trigonometry in here. There was just two places where we had to use trigonometry. Apart from it, it was all basic math. So this ends this video.